Hello everyone, very good evening. I hope you all are good. I'm doing well. Hanush, good evening, very good evening. So today in the class, we are going to wrap up current electricity by doing certain number of questions. So let's start from the question number 1. I hope you all remember the formulas. So let's start with it. Shunting means you understand, right? Adding that resistance in parallel with that particular thing. So shunting means adding this 2 ohm in parallel with the resistance. Okay. Okay, I got one correct answer so far, and another one feels incorrect. Take your time, think around it, try to solve, and then let me know your answers. Okay, so far 3 answers, all different. One is correct. Okay, Dhanush, yes, that is correct. Okay, should I discuss it now? I feel like so I should do. So let's discuss the question. Let's first read it. Okay. So what is the question given? Question is given that there is a meter bridge. So you already know what meter bridge looks like. Okay. And when a resistance in the left gap is 2 ohms, so there is a left gap here. And here resistance added is how much? This is the left gap, right? 2 ohm. And then what is, there is unknown resistance in the right gap. So let's say this is the right gap. And here the resistance is unknown. Let's say this is R. And the balance length is found to be at 40 centimeter. Let's draw this. I mean, there is nothing getting talked about the length of wire. So we will assume length of wire is how much? We have already dealt with this thing. This wire will be of length 1 meter. Then if nothing else is given, then this is of 1 meter. Now, what is given in the question? Balance length is found to be 40 centimeter. I have always told you balance length, whenever it is given in the question, 40, 30, whatever it is getting measured from which side? Left hand side. ठीक है? So यहाँ से 40 centimeter की बात कर रहा है वो. So let's say this is 40 centimeter. Then this will become how much? 60 centimeter. कुछ ऐसा होगा, है ना? And since here we are getting the null point in this setup, we can clearly write 2 by 40 will be equal to R by 60. है ना? We have learned this formula. If this is R1, this is R2. If this is L1 and this is 100 minus L1, so let's say L2, then we can clearly write R1 by L1 is equal to R2 by, मैंने क्या लिखा था? 100 minus L1. So this is L2 here basically. So it can be written like this. इसको आप 20 कर दो, ये 3 times से कट हो जाएगा. R का वैल्यू हमें मिल गया 3 ohm from the first thing given. Okay, now what we are doing on shunting the unknown resistance with 2 ohm. Now we are shunting unknown resistance with 2 ohm. Where is the known resistance? This is the unknown resistance. You are shunting it. Whenever you shunt things, you add that thing in the parallel. If you are shunting it with conducting wire, simply there is a resistor. You are shunting it with conducting wire means you will do this. Okay? If you are shunting any resistance with any other resistance, you are adding that in the parallel. This is the meaning of shunting. I have told you, right? So even if you got confused, no worries. Questions are, I mean, we do questions in order to learn. So let's learn it now. Are we are shunting with what? With a unknown, with known resistance of 2 ohm. So now we, second case को मैं draw करती हूँ. So second case, this is 2 ohm. Here there was R. ठीक है? एक second. Okay, so here this is R. And it is getting shunted by what? It is getting shunted by 2 ohm. And now it is like this. Okay? And here the wire is still the same, 1 meter long wire. This is how much long? 1 meter long wire. The balance length changes by what? Now the question is where we are going to get now the balance length. Let's say the balance length we are getting at L. Okay? So आप एक galvanometer ले लो. Let's say this is from this point we are getting a galvanometer like this and we are getting null point here. Let's say this is L1. Then clearly this will become 100 minus L1 or 1 minus L1 in terms of meter. Okay? So now let's calculate it. अभी अगर आप सिचुएशन मीटर ब्रिज का अगर फॉर्मूला आप रखते हो, what you are going to write in this case? So you will write 2 by L1. 2 by L1 will be equal to resistance of this part divided by 100 minus L1. So what will be the resistance of this part? 2 and R are in parallel. So this is 1 by 2 plus 1 by R. R 1 by R equivalent is this. So this is R plus 2 by 2R. So basically R equivalent is 2R by R plus 2. So let's write it here, 2R by R plus 2. We already know the value of R, right? That is equal to 3 ohm. We have calculated it here. And this divided by 100 minus L1. Let's put the values. 2R कितना हो जाएगा? 6. And 3 plus 2 will become 5. So this is 6 by 5, 100 minus L1. Now let's solve it. 2 से ये 3 times में चला जाएगा. And here you can get 3L1 is equal to, this is 500 minus 5L1. So this will become 8L1 is equal to 500. Now what is the value of L1? That is 500 by 8. If you are going to solve it, how much we are going to get? 620. So this 0.5, 62.5. Okay, and initially null point was where 40 centimeters. What is the change in null point position? Just give me some time. In the meantime, you calculate the change. ठीक है, चलो कितना आया चेंज बताओ, कितना चेंज हुआ null point में? Initially it was 40, now it is 62.5. So change is how much? 62.5 minus 40. If you are going to do this, you will get 22.5. So basically answer is 22.5 centimeter. So simply you needed to use meter bridge concept. Everyone clear with this question? Anybody doubt so far in this? नहीं, चलो ठीक है. Others please let me know. Lakshmi. Shravya, Lakshmi is not here. I can see. Mahesh. Chaitra, Nirali, Kiran, Karthik, Dhruv. Everyone clear with this question? Venu, Sri, सबका हो गया? देखो, nobody should leave the class at the time of question discussion. I'm telling you, this is more important than learning the concepts. It is far, far more important. I'm telling you. Karthik, thank you. चलो आगे बढ़ते. Let's now try this question. ठीक है? चलो. Take your time, do it. Now I will launch the poll for you so that you can answer again. Okay, read the question carefully. Try to draw the diagrams. That will help you. Lakshmi, you're losing the connection, I guess, you know? Yes. Yes, Lakshmi. मेन करंट का मतलब क्या है? मेन करंट का मतलब है द करंट यू आर गोइंग टू मेजर, करंट यू आर ट्राइंग टू मेजर. ओके, सो दिस इज द मेन करंट. दैट इज टोटल करंट कमिंग टू द अमीटर. चलो डू इट. लेट मी नो. ठीक है? Take your time. I'm giving you more time so that you can think more around this. Yes, anybody? Okay, I got two correct answers. That is great. Chalo, I gave you time and that is, I mean, I felt good because two answers at least I got. That's great. I hope you all must have tried it. Even if you couldn't get the answer, that is fine. You tried it, that is okay. ठीक है, Lakshmi. I will explain now. So, ammeter looks like what? Ammeter looks like this. Ammeter का सबसे पहले आप diagram बना लो. So ammeter looks like there is a galvanometer, then there is a shunt resistance connected with the galvanometer in parallel with it. Let's say its resistance is S and this its resistance is RG. And here G diya hua hai na. So let's not write it RG, let's write it G because its resistance is given, that is what? G. Now, what else is given? In a meter, 5% of the main current passes through the galvanometer. So, 5% of main current. कहने का मतलब, whatever current is coming from the battery, that is the main current, right? So, let's say यहाँ से I current आ रहा है. So, what is the main current value? That is I. This is I. This is main current. The current that is trying to enter the ammeter. And when it will enter the ammeter, it has two branches, one galvanometer wala and dusra is shunt wala. Okay? So what is going to happen? How much current will pass through the galvanometer? In an ammeter, 5% of main current passes through the galvanometer. So 5% of it. So 5% of I will pass through galvanometer, that is equal to Ig. ठीक है. So Ig का value is going to be how much? 5/100 into I. So that is equal to 0.05 I. ठीक है. So here how much you are getting? 0.05 I. How much will go through S? S के through कितना जाएगा बताओ? Yes, Kiran. That is correct. Okay, now everyone got it, I guess. Yes, Kiran. So this is, I mean, 0.05 I is coming here. So 95% will go this side. So 0.95 I will go this side. Okay. Now what we need to calculate is the resistance of ammeter. In order to calculate resistance of this ammeter, ammeter is this, right? It is this. Resistance of this ammeter will be equal to how much? Combination of two resistors S and RG in parallel. So 1 by R equivalent को आप क्या लिखोगे? 1 by S plus 1 by RG. RG is already given, that is equal to G. We need to calculate the value of S. So S का value आप कैसे निकालोगे? देखो यहाँ पे हमें पता है how much current is going through galvanometer arm and through the small resistance. Potential across this will be same as potential across this. So potential across galvanometer is how much? Current through galvanometer, that is 0.05 I into resistance of galvanometer G. What is the potential across S? Current through S, that is this, into resistance, that is S. And these two are in parallel. Potential difference is same. So equate these two. If you're going to equate these two, you will get the value of what? S in terms of G. So S value you're going to get at what? 5/95. So that is equal to 1 by, sorry, there is G here also. So G by 19. 5G by 95, that is G by 19. So this is the value of S. Done it? Everyone got it up to this point? Everyone got up to this point? किसी को doubt है? नहीं है, ठीक है, चलो, thank you. If not, then I will move ahead. So now what you can calculate is 1 by R equivalent निकाल दो. Because we were asked resistance of ammeter. Calculate it. 1 by S. S value is how much? G by 19. So G by 19 plus 1 by RG, that is G. So this is 20 by G. What is R equivalent? That is G by 20. So correct answer will be which one? C. Done it? So you just needed to know what ammeter looks like and what is the meaning of main current here. Main current means current that is trying to enter the galvanometer, enter the ammeter, not galvanometer, enter the whole ammeter. So ammeter consists of two branches, galvanometer branch and a small resistance branch, both in the parallel, right? So I use this concept to calculate the things. Everyone clear? किसी को doubt है, then you can raise your hand, you can unmute yourself, you can text me. Let me know.
No, ma'am.
Okay, thank you. Chalo. Now let's do one more question from, this is from what? Voltmeter. Okay? So let's do this. Think around the question. Don't worry if you're not getting the final answer. Because you're just starting, right? Even if you're not getting answers, but you are giving time in solving it, that is helping you indirectly. You may not see the direct result, but that is helping you. So everybody get invested. Try solving the question. Think around it. Okay, Tanush, I will slow down. Don't worry. I'm giving you people time. Don't worry. Okay, Kiran. Yes, it feels correct. Very good. So far, one answers in the poll that is not correct. Two answers not correct. देखो, you just need to understand the language of the question. Concept you already know, I guess. Concept समझ पा रहे हो? Maybe you are not able to decode the language. So listen carefully or read carefully the question that is written over here. There is a galvanometer. Draw the galvanometer. It has a resistance of 50 ohm. So Rg value is given 50 ohm. And it allows maximum current of 5 ampere through it. So through it, how much maximum current can go? That is always I have written as Ig. And okay, Kiran, ठीक है, चलो कोई नहीं. So Ig value here is given as how much? 5 milliampere. So this is the maximum current that galvanometer can accept. ठीक है? It can be converted into voltmeter. This is galvanometer. ठीक है? Rg 50 ohm. Maximum current that it can receive is 5 milliampere. Now, it can be converted into voltmeter to measure up to 100 volt. So range of voltmeter here is given. Range of voltmeter is how much? If you see here carefully, range of voltmeter is 0 to 100 volt. So up to 100 volt it can measure. And if up to 100 volt it can measure, then what value of resistance we need to connect with it in series? Because we have already learned how we convert galvanometer into voltmeter. We connect, we connect a resistor, a high value of resistor in series with the galvanometer. So let's say we are connecting R. This is your what? This is your voltmeter. Now, what is the maximum value that it can measure? 100 volt. So for maximum voltage to get measured, धनुष एक बार और ध्यान से देखो, मे बी कैलकुलेशन में मिस्टेक कर रहे हो. मैक्सिमम वोल्टेज कितना मेजर करना है? 200 वोल्ट नहीं, 100 वोल्ट. ठीक है. सो बेसिकली potential difference across this voltmeter maximum can be how much? That can be 100 volt. So let's indicate this by A, this by B. So maximum value VA minus VB. Yes, that is correct, Manus. So VA minus VB maximum can be how much? 100 volt. And VA minus VB are coming from where? Because here current is going, IG. And this current, because of this current, there will be potential drop on G and there will be potential drop on R. And sum of this potential drop will be equal to the total potential getting dropped across the voltmeter. क्योंकि voltmeter का total potential कितना होना है? Lakshmi, yes, very good. So total potential कितना होना है? 100 volt. Done. And that 100 volt will be sum of what? Will be sum of potential drop on the galvanometer and potential drop on the resistor. Write it now. So Ig ka value is already given 5 into 10 to the power minus 3 into 50. So this is potential drop on galvanometer. Potential drop on resistance R ko chalo aise likhte hai, and this is equal to 100 volt. Now if you solve it, you will get how much? This is okay, so this is 10 to the power minus 2.25, right? So 5 into 10 to the power minus 3 into R is equal to 100 minus 0.25, I guess. Yes. So 100 minus 0.25 will give you how much? That will give you 99.75. Clear? Eh? So this value we are going to get, R will be equal to how much? 99.75 divided by 5 into 10 to the power 3. So this will be equal to 1, and this is 9, and okay, and again how much? Again 9 and then 5. So this into 100 ऐसे कर दो, 1 0 will remain. So this is this. R का value is this. So correct answer is this. You simply need to use the concept of voltmeter. The next, so whenever you get question from ammeter and voltmeter, I am telling you it is going to be very easy. To the long you understand कि voltmeter क्या होता है, ammeter क्या होता है, ठीक है? चलो. Now let's do this question. Illumination of lamp will depend on what? Depend on what power it is consuming, right? Illumination means glow. It means how bright it is, right? So illumination of lamp means we are talking about power. Okay, I got one answer that doesn't ring true. I'm really sorry. You need to recheck your calculation. Please do it. Chalo, let's understand the question basically. Two answers I received, both are incorrect. So let's do it now. Let me get it done by my side or let's do it together. Okay? धनुष नहीं मिस्टेक हो रहा है कैलकुलेशन में मिस्टेक कर रहे हो तुम लोग मे बी वेनु सॉरी वेनु सेंट मी द आंसर यस सो इट डजंट रिंग ट्रू मे बी आप लोग कैलकुलेशन में मिस्टेक कर रहे हो ठीक है लेट्स स्पॉट इट नो वरीज यू पीपल ट्राइड इट दैट्स वेरी गुड so if current drops by 20%, current is dropping by 20%, then by what percentage illumination that is power will decrease. ठीक है so अगर current decrease होता है by 20%, by what percent power will change. ठीक है that we have to calculate. Tanush नहीं that's not the correct. So initially let's say there is I current flowing through this lamp. Let's say this is your lamp, and through this I current is flowing. What will be the power initially? I square R. So this is your initial power. Now what we are doing in the second case, current is getting dropped by 20%. Getting dropped by 20%. There is two statements that can be here. Current dropped to 20%. Current dropped by 20%. So 20% ऑफ पहले करंट आप निकाल लो 20% ऑफ आई कितना होगा बताओ 20/100 into I so that is going to be I/5 so here current is not getting dropped to I to 20% अगर स्टेटमेंट ऐसा होता कि current is getting dropped to 20% then you would have written कि final current is I/5 but here it is getting dropped by 20%. So you will say final current is I minus I/5. ठीक है so final current I minus I/5 final current आप यहाँ पे लिख डालो कितना होगा I minus I/5 so this is equal to 4I/5. Now in final case let's draw it like this current is this way then what will be the power final power is I square that is 16I square by 25 if I'm not wrong. And this into how much you will get? R. Okay. Now, by what percentage will the illumination of lamp decrease? By what percentage it is decreasing? So, percentage change in the power. आप कैसे निकालोगे? You will calculate final power minus initial power divided by initial power into 100. This is how we do the calculation, right? So, final power को आप initial से subtract करो. बट यहाँ पे फाइनल पावर कम है तो ये टर्म हमें नेगेटिव आने वाला है सो 1 माइनस 16/25 करोगे कितना आएगा बताओ 9/25 सो 9I/25 इंटू वॉट 9PI/25 into PI into 100 so this will get cancelled and percentage we are getting as how much percentage we are getting as 36%. So this will be the answer. Answer will be your B, not C. 46% नहीं होगा 36% होगा ठीक है अगर तुम्हारा करंट टू स्टेटमेंट में होता देन I/5 होता है देन फाइनल पावर वुड हैव बीन I² by 25R है ना एंड इन दैट केस अगर आप परसेंटेज निकालते तो कितना जाता 24/25 एंड इन दैट केस 96% होता ना ठीक है so I don't know how you people were solving it but is it clear now you spotted the mistake what happened देखो गलती करना बहुत जरूरी है if you are not solving and then looking at the solution no help if you are solving it right or wrong doesn't matter and then you are checking the solution or seeing the discussion it is helpful it is very much helpful so anybody who has still problem in this question let me know otherwise we will move on with next question okay Lakshmi thank you someone with Dell what's your name please can you let me your name let me know your name please that would be helpful चलो, let's do this question now. We are going to learn also in this question. So आप लोग पहले try करो, then I will let you know. गलती करना बहुत जरूरी है, मैं बार बार रिपीट करती हूँ, दिस इज वेरी इंपॉर्टेंट. Okay, I got one answer and it doesn't look correct. ओके, एक काम करते हैं, इस क्वेश्चन को साथ में सॉल्व करते हैं, ठीक है? लेट्स डू इट टुगेदर. टू आंसर्स, थ्री आंसर्स सो फार. I couldn't get any correct answer. Four answers. Anyway, but you tried it. I've given you long 2 or 3 minutes for thinking on this question, and that is enough for me now. Okay? Venu, it doesn't look correct. I'm really sorry, but it is like this. चलो डिस्कस करते हैं, मजा आने वाला है इस क्वेश्चन में. It is really a good question. Let's do it. So what is the case? There are two conductors. They have the same resistance at 0 degree. So let's say this is uh, since we are talking about resistance, I will draw it in terms of registers. ठीक है, ऐसा. So this is first register, this is another register. ठीक है, both are having same resistances. Tanush, it doesn't look correct. ठीक है, both are having same resistance. At what temperature? At 0 degree. So at 0 degree, both are having same resistances. Now their coefficient of resistances are different. Coefficient of resistances for first one is alpha 1. Let's call this wire 1 and let's call this wire 2. This is alpha 1 and this is alpha 2. Okay? Now the respective temperature coefficient for their series and parallel combinations are what? So question ये हमसे पूछ रहा है कि if you are going to join these two resistors, let's say we are joining them. So this combined rod will have what value of alpha? This is the question. So we cannot directly write कि ये alpha 1 plus alpha 2 होगा. We need to follow certain concept things, right? So basically we are combining two rods like this. Maybe they are having different cross, no, they are having different cross sections, maybe. but resistance of both at same at 0 degree same. And then we are combining it like this in series, that is end to end we are joining. And then we are asking what is the alpha of this combined conductor. Okay, so how we will do this? Let's say this combined resistors has a resistance of how much? Since we are combining in series, it will have resistance of 2R naught at what temperature? At 0 degrees centigrade. Okay, so let's calculate at any other temperature T, what will be its resistance. For 3 cases, let's do this. So मैं क्या कहने जा रही हूँ, फर्स्ट केस में अगर मैं पूछूं व्हाट इज द रेजिस्टेंस ऑफ फर्स्ट कंडक्टर एट टेम्परेचर T, ठीक है. सो व्हाट यू विल राइट द फॉर्मूला. सो रेजिस्टेंस एट टेम्परेचर T यू विल बी राइटिंग एज, so let's indicate it by letter R1. So let's say R1 is equal to, what will be the formula? R naught 1 plus alpha 1 delta T. So what we are calculating? We are calculating resistance of first conductor when temperature is getting increased by delta T. Okay, so this will be the thing, because this we have learned from the formula. This is the formula, right? This is how resistance changes with the temperature. So this is the formula. Second के लिए अगर लिखो आप कि second का resistance कितना बढ़ा होगा. So we will say that R2 at by R2 value after the increase of delta T temperature will be R naught 1 plus alpha 1 delta T. Okay, and here if I talk about this combined rod system, alpha 2. Yes, so alpha 2, yes, sorry, alpha 2 delta T. This is what I can write. अब देखो इस combined के लिए आप लिख लो, इस combined का resistance is 2R naught at 0 degree centigrade. Let's say when we increase the temperature by delta T, this combined has a value of resistance R equivalent, and this is equal to 2R naught 1 plus alpha delta T. ठीक है, और R equivalent से अगर confuse हो रहे हो तो let's write here simply R something R. R is 2R naught 1 plus alpha delta T. ठीक है, because at 0 degree it is 2R naught, at any temperature T it is R is equal to 2R naught 1 plus alpha delta T. What is the relationship between 1, 2 and 3? If I write this 3, what is the relationship between 1, 2, 3? You already know R1 plus R2 is equal to R, है ना? Because we have joined them to form a combined conductor having resistance 2R naught. We have joined them in series, simple. So R1 plus R2 will be equal to R. Done it? Because at temperature T, it has a resistance R1. At temperature T, it has a resistance R2. At a temperature T, it has a resistance R. So clearly R is equal to R1 plus R2. Now you put the values. अगर आप values put करोगे यहाँ पे तो क्या मिलने वाला है बताओ? R naught 1 plus alpha 1 delta T plus R2, that is R naught 1 plus alpha 2 delta T, and this is equal to how much? 2R naught 1 plus alpha delta T. Now let's do the calculation. So if we go on to solve it, this R naught plus this R naught will become how much? 2R naught, and this is R naught alpha 1 delta T. So यहाँ पे आप लोग लिख लो R naught alpha 1 delta T, and this is R naught alpha 2 delta T, and this is equal to 2R naught plus 2R naught alpha delta T. Now this will get cancelled, and R naught will get cancelled from the both side. And if you solve it further, क्या दिख रहा है हमें? हमें ये दिख रहा है alpha 1 plus alpha 2 delta T is equal to how much? Alpha 1 plus alpha 2 into delta T is equal to 2 alpha delta T, right? R naught को हमने cancel कर दिया दोनों side से, so this is 2 alpha delta T. Delta T will also get cancelled, and from here we are getting alpha का value. Alpha is how much? Alpha 1 plus alpha 2 by 2. So first का आंसर मुझे मिल गया. आंसर क्या होगा सीरीज के लिए? Alpha 1 plus alpha 2 by 2. So either option B can be correct or either option D can be correct. इन दोनों में से कोई एक करेक्ट हो सकता है. ठीक है. Now we need to check which one is going to be correct. That is our concern, right? क्या होगा बताओ. अब पैरेलल का कैसे सॉल्व करोगे किरण? पैरेलल का पहले सॉल्व करना पड़ेगा किरण. यू आर रॉन्ग. चलो पैरेलल का सॉल्व करते हैं. सो पैरेलल के को सॉल्व करने से पहले एक चीज मैं तुम लोगों को बता दूं वहां पे क्या यूज में आएगा. एंड दिस थिंग यू शुड लर्न बिकॉज इन वेरियस फिजिक्स क्वेश्चन दिस कॉन्सेप्ट विल कम इन टू यूज. ठीक है. And that concept is that also in electrostatics I talked about it. So I talked about one thing. If there is equation of this sort, 1 plus x to the power n, then this can be written as 1 plus nx when if x is far, sorry, not x, yes, x. So if x is far less than 1. ठीक है. This is the thing I told you. And here let me quote another truth. And truth is that अल्फा का जो रेंज होता है ना, that is of the range of 10 to the power -5 or -6. So alpha is actually very much less than that of 1. ठीक है. So इन दो चीजों को ध्यान में रख के we will solve for parallel. अब देखो पैरेलल में मैं क्या करूंगी. 1/r1 plus 1/r2 is equal to what? I mean अगर आप पैरेलल में जोड़ोगे उन दो रेजिस्टर्स को जो हमारे पास था, then you will do like this. ठीक है. R1 R2 is not going to change, but if you talk about R equivalent at 0 degree, then that will become how much? This is R0. जैसे यहाँ हमने सीरीज में किया ना, R0 plus R0 at 0 degree became 2R0. They were in series. So here R0 and R0 in parallel at 0 degree. If you write here at 0 degree, this will become how much? R0 by 2. ठीक है. So at any random temperature, what will be its value? So at any random temperature, let's say it is R. So R will be equal to R0 by 2, 1 plus alpha delta T. And we need to calculate this alpha. ठीक है. So basically, what is the relationship between R1, R2 and R here? R1, R2 are these individual resistors. Value at temperature T. R is the value of combined resistors at temperature T. So 1 by R1 plus 1 by R2 is equal to 1 by R. अब आप एक काम करो, वैल्यूज को पुट कर दो. And if you are going to put the value, 1 by R1 को आप क्या लिखोगे बताओ. You will write 1 by R0, 1 plus alpha 1 delta T. And what this you are going to write? 1 by R0 again, 1 plus alpha 2 delta T. And this will get equated to what? R0 by 2. So let's write here 2. 1 plus alpha delta T. R0 को आप कैंसिल कर लो. ठीक है. कर दिया हमने कैंसिल. अब क्या करते हैं हम. चलो अब एक काम करते हैं. इसको क्या लिख सकते हैं. दिस इज 1 by 1 plus alpha 1 delta T. इसको आप लिख सकते हो 1 plus alpha 1 delta T का पावर -1 लिख सकते हैं, है ना. प्लस 1 plus alpha 2 delta T का पावर क्या है? -1. And this can be equated to 1 plus alpha delta T का पावर क्या होगा? -1. This is what we are getting, right? And देखो ये सब हम ना प्रैक्टिस से ही सीखते हैं कि इसको -1 क्यों किया. मैंने इसलिए किया so that I can use this. Yes. Sorry. Let me know if you have doubt.
Minimum 2.
Yes. B will be the option. Yeah. That's great. So अब देखो अब इस चीज को आप यूज करो. 1 plus x, 1 plus something. X is alpha 1 delta T. Delta T is a small. Alpha 1 is of the range of 10 to the power -5 and -6. It is far less than 1. So 1 plus x to the power n को हम क्या लिख सकते हैं? 1 plus nx. Here n is equal to how much? N is equal to -1. Here also n is equal to -1. Sorry. Yes. And here also n is equal to -1. So 1 plus nx. 1 n क्या है तुम्हारा? -1. से माइनस लिखो. x क्या है? अल्फा 1 डेल्टा टी. अल्फा 1 डेल्टा टी आप लिख डालो. प्लस 1 minus alpha 2 delta t will be equal to 1 minus alpha delta t. When I started this class, I mean this session basically in the electrostatics time, I told you this is going to be a very important formula. So see here, now we are using it, right? So if you see here what we can see, यहाँ पे हमने कुछ मिस्टेक किया ना, यहाँ पे 2 था, this 2 was there, right? हमने उसको मिस कर दिया. So this is your 2. ठीक है. 1 plus 1 2, and that 2 will get cancelled from here, right? So minus alpha 1 delta t minus alpha 2 delta t is equal to minus 2 alpha delta t. Delta t will get cancelled, and alpha is equal to alpha 1 plus alpha 2 by 2. So same as parallel we got here. Same as parallel we got here. So correct answer should be what? It should be B. I hope you have understood this question. If not, you can let me know. ठीक है. ये कॉन्सेप्ट तुम लोगों को अगर तुम लोगों ने थर्मोडायनेमिक्स का कंडक्शन पढ़ा है, कंडक्शन मेथड, हीट ट्रांसफर, then in conduction method also we used to calculate K equivalent. If you remember thermal conductivity ka equivalent, there we used to do the similar thing. If you remember, if you have done that, then similar thing we have done there also. So this is a very important question. You should practice doing it again. I mean, in order to keep it in your mind. I'm not telling you to remember it, but yes, this concept should stay in your mind, because around this you will be getting many other questions. This came in JEE Mains. This is a PYQ of JEE Mains. Yes. ये क्वेश्चन कुछ नहीं है, मैं बता रही हूँ. तुम लोग जब क्वेश्चन बहुत सारा कर लोगे ना, यू विल फील लाइक दिस इज नथिंग. ठीक है. सो you are feeling the weight of question. Why? Because you have not carried it much. Let me tell you, you have not done much. That is why. अभी आप क्वेश्चन और ज्यादा प्रैक्टिस करोगे, this question will start becoming or start getting easy. ठीक है. So yeah, but you can say this is a good question. चलो. Now let's do this question, and after that we will finish the class. ये हमारा अच्छा क्वेश्चन है. This question is from अमीटर, I guess, है ना. चलो, ये क्वेश्चन डिवीजन से है. And if you have followed concept clearly, you can do it. I cannot say कि if you have followed, you have followed the concept, and if you're not able to do it, then I will say you have not followed it. It's not like that, but maybe you will be able to do it. But try it. You can do easily, but it's all about practice again. Yes. Okay, it has been 2 minutes. So let me explain this question to you, what it is trying to say in, or how you can go around this question. So it is saying that there is a galvanometer and the deflection in moving coil galvanometer is a type of galvanometer that we will read in magnetism. Don't worry. So this is a galvanometer and deflection falls from 25 division to 5 division when a shunt is getting applied. So let's talk about here. There is a G. Okay. Initially, there is no shunt connected. And after shunt is getting connected, there will be resistor here. This is a small resistance value. So before, whatever current was coming here was passing through the galvanometer because here there is no other branch. And now, if the same current you allow to pass, then what will happen? Some current will go this side, some will go this side. Okay. So initially what it is said, deflection is falling from 25 division to 5 division. Let's say for each division for deflection of one division, I amount of current is required, let's say. So in the first case, 25 division deflection happened. So let's say 25 I current was required for that. Okay. I assume per deflection के लिए how much current we require? I. And in the question, it is given that initially 25 division deflection is happening. It means what? Uh, it means, yes, Kiran, you are right. So 25 I current I have assumed here. So 25 I current is entering. Now what is happening? 5 division deflection is happening. It means in this direction, 5 I current is going. And in this direction, how much? 20 I current. You will divide it like this, right? Because division is dropping from 25 to 5. I have taken for each division we require I current. So initially 25 I current is there, I assume. And finally, when we are shunting it, 5 I current will go through the galvanometer, 20 I through the same shunt resistance. Okay? And shunt ka value is given, that is 24. We are asked the resistance of galvanometer. Simply use the concept of galvanometer. What does it say? It says that potential difference across galvanometer is equal to potential difference across the shunt. So across the shunt, what is the potential difference? 20 I into 24. And what is through the galvanometer? This is Rg into 5I. So if you solve it, now you will get the answer. So this is 4 and Rg will be equal to how much? This will be equal to 96 ohm. I hope I am able to explain it to you. You got this concept or not? Let me know if you're having doubt then. Yes, anybody. You can come out with your doubts. Okay, Kiran, thank you. Lakshmi, you got it? Shravya? Tanush, it happened? Okay. सबके लिए okay है? Sanu? Sanjana? Priya is not here today. Mahesh, Latika, Chetra, Kiran, Karthik, Adi.
Okay, ma'am.
हो गया? चलो. It's great. Then from tomorrow we are going to start with what? We are going to start with magnetic effect of electric current. ठीक है कार्तिक? ठीक है, थैंक यू. लेकिन तुम लोगों का टास्क खत्म नहीं हुआ है. You have to keep solving more number of questions. ठीक है? So still you are having so much work to do. Do more number of questions from current electricity, from capacitor, from electrostat. Keep on practicing more number of questions. Only mantra for getting into any good college is solving question. First, you should know the basic concept that I have already given you. So you know the basic concept. Now you should attack questions. Keep attacking it. That will reach you benefit. Okay? Chalo. Everyone take care of yourself.
Bye, ma'am.
Bye-bye. Tata. Take care. Okay, Karthik. Bye, Kiran. Thank you. Everyone take care of yourself. Have tea. Enjoy. Have more family time in the evening. ठीक है? चलो मजे करो सभी लोग, दोस्तों से मिलो. संजना, बाय बाय. Thank you, Lakshmi.